Hello everyone, welcome to the 7th video tutorial for Intel Galileo Gen 1 development board. In the 6th video, we saw how to auto-start an application on boot up with the help of an LED blinking through web page example. In this video, we will try to demonstrate interfaces such as GPIO, ADC and I2C with the help of examples. To demonstrate GPIO interface for input and output, we will try to switch on and off LED with the help of button connected to Galileo as a GPIO. In the earlier videos, we have just exported an onboard LED connection to GPIO 3 as output via sysfs and tried controlling from Linux console and web page. In this part of the tutorial, we will use a switch button connected to Galileo via GPIO. If the switch is pressed, the onboard LED will turn on, and if the switch is not pressed, the onboard LED will be turned off. In the second demonstration, we will use light sensor and read analog values as the light intensity changes. In the third demonstration for I2C interface, we will be using a 16x2 character LCD connected as a slave to Galileo. We will try to glow the LCD backlight and print some test characters on the LCD. Let us now start with the first part of the tutorial, which is to demonstrate GPIO interface. For the purpose of this demo, I will be using two components from Grove Starter Kit by Seed. Grove Starter Kit provides a base shield which resembles an interface between any Arduino shield interface with Galileo. The base shield is divided into three different functional areas, that is 8 digital ports, 4 analog ports and 4 I2C ports. For this demo, we will be using digital ports for GPIO. We will use the Grove button to turn on and off our onboard LED. We will place the base shield on top of Galileo as any Arduino shield. Next, we will connect the Grove button to any of the 8 digital ports on the base shield. In order to map the sysfs ports to the shield interface, Mutex Labs have created a Python wiring module which is simple and unified API similar to the wiring Pi module to talk to GPIO pins on the board. This wiring Python module is compatible for even Edison, Galileo Gen 1 and Gen 2 Arduino-like interfaces. We can download this from GitHub URL given on the screen. Once clone is created, we can install this module by typing python setup.py install. Inside this directory, we can see examples folder, wherein basic examples are created for Edison. We will try to modify one of these examples for Galileo Gen 1. In the examples directory, we can see example button.py, which is basically using the Grove button to turn on Grove LED. We will try to turn on the onboard LED instead of a Grove LED. Let us copy this file with name button_galileo.py. Let us now go through this file and make required changes for Galileo. Please note the example here was to turn on a Grove LED, but we will be turning on an onboard LED with the help of Grove button. Thus, we will also have to make required changes where the example would set up for LED interface using wiring module. We will not need this wiring interface since our onboard LED is connected to a GPIO on Galileo, but not through Arduino interface. I hope I am able to make you understand where the difference lies between both the LEDs. Initial lines are comments by the developer. Next, we see GPIO Galileo module imported from wiring x86 as GPIO. Next, we create an instance of class GPIO and name it as GPIO in lowercase. In the next line, we will see two initializations. One of them is for pin, which refers to the Grove LED digital port, and the button refers to the Grove switch button. At this point of time, I would like to discuss a little more about the wiring x86 module. Let us go back and open the wiring x86.py file. In this file, let us search for GPIO_mapping. We see here how sysfs ports are mapped to the Arduino-like interface. The number on the left is the Arduino interface number provided to the wiring x86 module, and the number on the right is the corresponding GPIO ports. Similarly, we have for ADC and PWM mapping. Many ports are multiplexed. The wiring module also takes care of the mux selects that is required depending on the application. So in our example, when we connect the Grove button to port D2 on base shield and referring to the diagrams given on the screen, we see that port D2 of the base shield is connected to port IO2 on Galileo board. Now referring to the pin mux diagram, we can see that for port IO2 on Galileo, we need to set mux select, that is GPIO 31 to 1, and then read the values through GPIO 32. Wiring x86 Python module basically implements this muxing and interface. We just saw one of the examples of it. Once we have modified this existing example code for our demo, we verify that what we have interpreted from the pin muxing and interface diagrams with the help of debug option. We will simply remove the pin interface and insert our sysfs LED blink Python from earlier tutorials. So, in our button_galileo.py, we will simply remove the pin interface and insert our sysfs LED blink Python scripts from earlier tutorials. We will delete the line pin is equal to 3 and the line gpio.pinMode pin.gpio.output. Instead of these, we will insert our pins_export function to export sysfs gpio3. Here, we will also insert our function to write values to the gpio3. We will not change anything for the lines of code for the button interface. Next, in the while loop, we will change the function call for digital write to write_LED function call that we created above. We will now save and close the file. Next, when I execute this Python script, we see that the LED is initially turned off because button is not pressed. When I now press the button, the LED turns on. Next, when I release the button, the LED turns off. Now when I make the option debug is equal to true in the button_galileo.py, we can see some debugging prints on the console. Let us try that out. So as we can see on the console, it exports GPIO 31 and 32. It sets GPIO 31 to 1 and sets GPIO 32 direction as input. This verifies our earlier interpretation and ends the part 1 of this video tutorial. In the second part of the video tutorial, we will demonstrate the analog interface using Grove Light Sensor module. We will connect the module to one of the analog ports on the base shield. We can verify the analog mappings in the wiring x86.py. In the examples folder, we can also find an analog_input.py for Edison. Let us copy this file with the name analog_input_galileo.py. Let us open the file and make required changes. We will import the modules GPIO Galileo and time in this example to sample the analog values. We will remove lines of code for pin which is connected to Grove LED. We will display the sample analog values on the console. So we will remove lines pin is equal to 13 and line gpio.pinMode pin gpio.output. Next, in the while loop, we will continuously read analog readings. We will print this value to the console. We will give a sleep time of 0.2 to be able to view the values. We will now save and close the file. When I now execute the script, we see that it gives value around 750. As I bring my hand closer to the light sensor, the value goes on decreasing. And when I take my hand away from the sensor, the value again increases. So this ends the basic demo for analog interface available on Galileo. In the third part of the video tutorial, we will demonstrate the I2C interface on Galileo using Grove LCD. We will connect Grove LCD to one of the I2C ports on the shield. More specifically, it is connected to the SM bus, which is the system management bus. SM bus is derived from I2C for communication with low bandwidth devices on a motherboard, especially power related chips. We will follow the post on Intel Developer Zone. Link to the post is given on the screen. This post explains how to set up Grove LCD with Raspberry Pi. I have already downloaded the folder wiring.zip. You can download this folder from the URL given on the screen. We should be able to use same libraries for Galileo. In order to use this library, we will have to install the Python SMBus module on Galileo. We can install Python SMBus by following the steps given on the screen. Please make sure that we use --force -override switch while installing uselibc package. Because if we do not use this switch, we get an error saying that this package wants to update libc6 package. Please use this switch and do not remove libc6 package. I repeat, do not remove the libc6 package. Once we have Python SMBus installed, we will change the directory to wiring, which we downloaded earlier. We can see various LCD-based Python scripts in this folder. We have a Grove LCD lib.py, which defines various functions to use LCD over SMBus. Next, we have Grove LCD test.py script, which tests the LCD interface with Galileo over SMBus. Since these examples do not use wiring module for interface, we will have to specifically mention all the pin muxing details in the script. Once again, we go back to our interface diagrams. We see that I2C ports on the shields are connected to A4 and A5 ports on Galileo, which are SDA and SCL lines respectively. When we refer to a pin muxing diagram, we see that in order to select SDA and SCL on ports A4 and A5, we need to set GPIO 29 to 0. So I have created a Python script named setit2cgen1.py. In this file, using our earlier knowledge of sysfs, I have set GPIO 29 to 0. Please note that the same script could be used for Galileo Gen 2 with a minor change in pin muxing. In case of GPIO 29, we will have to set GPIO 60 to 0. We can refer to the table given on the screen for Galileo Gen 2 board. Once the setup for I2C is done, we will look into Grove LCD lib. It describes functions for two controllers in the LCD, one of which is for the screen and the other one for the backlight. Next, we see the Grove LCD test script. Here, we will import Grove LCD lib module and SMBus module for Python we installed. We will select SMBus 0. We will initialize the LCD screen and backlight by passing on their I2C addresses. We can refer to the table given on the screen to find out the I2C addresses for various seed products. Then, using certain functions for screen and backlight, we will change the backlight color to red, then green, and then blue. We will simultaneously print text on the LCD screen. Let us now execute the script. We can see the LCD backlight color changing. We can also see the Hello World displayed on LCD. Next, it displays testing colors. So this ends the demo for I2C interface on Galileo. Thank you for watching this video. I hope you enjoyed it.